Hello everyone and welcome to this new video, in which we will continue to improve our bolt gun by discovering new modeling tools. Let's keep working on the magazine by modeling its base. This time we will model these two objects in a single geometry, which is as far as possible the best way to optimize a 3D model. So to start, we first delete the old base with the X key, and we will learn how to extrude faces. Let's do this right away. To extrude a face, let's select the magazine, switch to edit mode with tab key, and switch to face selection with the 3 key. We'll extrude this face, so I select it, go to face menu, then choose extrude faces, then Blender start to extrude the face. So basically, a face extrusion is like moving the face, but at the same time, the extrusion create other faces in order to keep the extruded face connected to the geometry. Let's cancel what we just done for the moment and start again with other faces so you will understand well. This time, I use a shortcut to extrude faces, which is the E key. And like we just did, we move the face, but it remains connected to the model because Blender creates as many faces as it takes to connect each edges to its original location. We can also extrude several faces at the same time, and it gives us that. It works exactly the same way. So I cancel all that, and we will extrude the bottom face in order to create the main volume of the base. So with the E key, we extrude the face around there, so we now have a face loop for the base. Then we will extrude these 4 faces to represent the thickness of the base. I'm talking about this small right angle we can see here, because the base of the magazine is wider than the magazine itself. So with the faces selected, I press the E key to extrude, but there, we can see that it doesn't behave at all like before. We already said that when we're extruding faces, we kind of move them. But when we move faces, we can only do it in one direction. We can always change direction with Y key to extrude along the direction of the Y-axis, the X key to extrude towards X, or the Z key to follow the Z-axis. But each time, we extrude our 4 faces in a same direction, whereas what we want is each faces to be extruded with its own orientation toward directions perpendicular to themselves. So we will have to proceed differently. So let's cancel all that. There are 2 methods to do this correctly. The first will ask us to learn what normals are. You may have heard of it before, but for those who don't really know what it is, I'll have to explain it to you, and you'll see it's a bit theoretical. So I prefer to talk about that in the second part of the video. At first, we will rather use a somewhat DIY method. But it's good to learn to tinker in 3D because by tinkering you can succeed in doing almost anything you want, even if you don't know the most suitable tool. But above all, tinkering will allow us to manipulate a little bit with simple transformations. So let's start with the tinker method. Let's extrude again our 4 faces. So we press the E key, but we do not validate anything. We do not touch the mouse buttons. As I explained just before, when we are extruding faces, by default, Blender proposes us to use the Move tool to determine the new position of the faces. But, as we have just seen, a translation can only be done in one direction, and our 4 faces are oriented differently, so it does not work. But on the other hand, we can use another type of transformation. Using the Move tool is just a default behavior. So I can press the R key to set extruded face's new position with a rotation, which in the present case does not really help us anymore. But if I can use rotation, I can also use the scale tool. So let's press S key to scale our faces, then it becomes much more interesting, since a uniform scale deforms an object in all directions at the same time. On the other hand, this operation did not give us exactly what we wanted. We extruded much more in width than in depth, and since we made a uniform scale, extrusion has also deformed the faces on their height, which created this small bevel that we would have preferred to avoid. This is somewhat the limit of this technique, so we will have to correct things by tinkering, but we will be able to do it with basic transformation tools. So we're going to start by adjusting the width. So I select these two faces. I set a side view well aligned on the y-axis. With Alt-Z I switch to transparency, and with S key, I do a uniform scale to adjust the width of the base. We're going to do the same thing for the thickness. With S and Y keys, I scale the faces along y-axis, which moves our faces only along y-axis. And it doesn't look too bad like that. Then we will flatten the upper surface. So for that, we first switch to Edges Selection mode with 2 key, then select these 4 edges, the edges of the upper inner part of the base. The idea is simply to raise these 4 edges to align them in height with the outer segments. We will immediately do it using the Z-axis. It's not too bad, but if we exaggerate the translation, we realize that in fact, the direction of the transformation is not perfect. It is simply because we are using axis global orientation, so we are moving edges straight up, whereas we want to move the edges along this edges orientation, and indeed if I select this segment, we can clearly see there is a significant angle between both axes. Instead, we could have moved the segments on both X and Y axes, and that's starting to get pretty convincing, but we'll try to do even better. For those who have followed the tutorial about axis local orientation, you could think that the solution is to switch to local orientation, but unfortunately not. Since the local orientation concerns the orientation of the object itself, and not the data that compose it. This is obvious if we think about it, because all edges and faces of the objects are all oriented differently. If I select this edge, which is the direction in which I'd like to move my selection, I see that the local orientation of the object is not aligned with the edge at all. But fortunately, we will be able to use another very nice tool that will allow us to slide vertices, edges, or faces. So we select the 4 edges again, and for triggering the slide tool, we hit G key twice. So the first time we triggers the move tool aligned to the view that we already know, but which is useless here. And the second time we hit G, we trigger the slide tool. So in other words, the short key is simply double G like that. So as you can see, the sliding tool moves edges along one of the 2 adjacent edges of the selection. So here I move the edges along the direction of the edge underlined in yellow, and I can also do it along the other adjacent edges, which are in the corner. To switch between those 2 orientation, just move your mouse closer to the edges you want to use. So in our case, we want to use the vertical edges orientation to raise our segments. So let's slide along this edges instead, trying to do something not too bad, and we're going to say that it's pretty good that way. So this double G shortcut is very useful. It allows, for example, if I want to adjust the spacing between these edge loops, well, I select a loop and I hit double G, and it allows me to move the loop, not by following any of global or local axis, but by sliding along the adjacent segments without breaking others' edges shape. It's really very practical. There you go. Sorry if everything is not perfectly clear. I try to explain the theory while I show you the practice, so you can understand what is happening. A large part of 3D modeling tools are just different methods to do the same thing from a mathematical point of view. So if you understand a little bit of theory about axis, etc., it will allow you to understand very easily next tools we are going to learn later. Finally, I think this video is long enough. I want to keep a short format for this video series. So I'll explain the second method to extrude using normals in the next video. Thanks for watching this one, and I'll see you soon.